Superstring theory is known for its postulation of extra dimensions beyond the traditional 3 dimensions of space and 1 dimension of time that we know. Think of our world as a flat piece of paper. Boring? Right. But what if, like a pop-up book, there were hidden layers to our universe? That's the concept of higher dimensions in string theory. In string theory, particles like electrons and atoms are not just points in space, but tiny strings that vibrate at different frequencies to create the particles we know in our world. Imagine if you were a tiny string that could vibrate in various ways to form different particles. But wait, there's more. What if, in addition to vibrating up, down, left, and right, you could also vibrate in another direction in a higher dimension? That's the magic of higher dimensions. String theory requires extra dimensions for a few reasons. First, it provides a simple explanation for the weakness of gravity compared to other forces. In string theory, gravity is mediated by closed strings, which are loops of energy that exist in all dimensions. The closed strings can move freely in the extra dimensions, but are confined to a smaller, compactified space in the 3 dimensions of space and 1 dimension of time that we know. Secondly, extra dimensions provide a way to unify the different fundamental forces of nature. And lastly, they are necessary to solve mathematical inconsistencies that arise when trying to unify quantum mechanics and general relativity in 4-dimensional spacetime. They provide a self-consistent mathematical structure that solves these problems by allowing for the existence of a higher dimensional spacetime in which both quantum mechanics and general relativity can be incorporated. In this framework, the quantization of matter and energy in the extra dimensions can account for the probabilistic nature of quantum mechanics, while the geometry of the extra dimensions can account for the curvature of spacetime described by general relativity. So, how many dimensions are there in string theory? Well, it's a bit like a choose-your-own-adventure book. There are different versions of the theory that predict anywhere from 10 to 26 dimensions. Can you believe it? The most popular version, M-theory, predicts that there are a whopping 10 dimensions in our universe. 9 spatial dimensions and 1 dimension of time, like the pages in a pop-up book. But here's the catch: these extra dimensions are so small that we can't see them in our everyday lives. It's like they're curled up into a teeny-tiny size, the size of the Planck length, hiding from plain sight. The Planck length is the smallest possible length that has physical meaning in the universe. In comparison, if a proton were the size of our galaxy, then the size of the string would be as big as a tree. The extra dimensions in string theory are compactified and curled up into a small, unobservable size through Calabi-Yau compactification. Think of the extra dimensions as a fabric and the Calabi-Yau manifold as a shape that the fabric is wrapped around. The fabric is curled up around the shape, making the extra dimensions small and unobservable. Thank you for joining me on this journey.